question 8 starts off with a trapezium rule. Now the trapezium rule is in your book, it's on page 8, unlike most of the core 2 formulae, which is on page 4. However, lots of people find they can just remember it. So first thing we want to do is it wants us to use 5 ordinates, which is 4 strips, to find a value with an integral between 0 and 2. So we've got to split that into 4 strips. You can see now I've got 5 lines. So that's going to be 1, that's going to be 0.5, that's going to be 1.5. And then do a table of values. Now I've worked out what my x values are. So 0, 0.5, 1, 1.5 and 2. In this case the equation is, well, I'm doing y, I'm just calling that 6 to the power of x. So that's quite easy to do exactly. If I put 0 into that, if I get 1, 6 to the power of 0.5 is root 6, 6 to the power of 1 is 6, 6 to the power of 1.5 is going to 6 root 6, and 6 squared is 36. If you're not confident with that, you can use your calculator to get values, or if it's something more complicated, we go into table mode, we put in our function, press equals, start is the lower limit we want, end upper limit, step. Now this is the same as h in the formula. How much do we want our x's to go up by each time? And we'll get a table of values. The thing to note here is in the table, f of x is y, this will be truncated, not rounded. So if you're copying from the calculator, be careful. This value is actually 2.4495 because you need to round up, whereas the table shows 4494. So just be aware of that, use the buttons to scroll down. Right, once I've done that, I'm going to use the trapezium rule. Okay, so what does the trapezium rule tell me? So the trapezium rule tells me that the integral is approximately a half times h, so h is the same as the step size, it's what your x's are going up by, so 0.5, times, now y0 and yn means the first y and the last y. So in this case that's 1 plus 36 plus 2 times the rest of them. So 2 times all the y's in the middle. So that's root 6 plus 6 plus 6 root 6. You should use every single y in your formula. If you haven't, then you've missed one out, you've done something wrong. So I can check that I've got 5 y values in my formula. Now you can type that into calculator exactly as is, and it will come out correctly, and it will tell you it's 20.823. Check the question. We wanted 3 significant figures, so that's 20.823 fig. One thing it's worth noting here, the sort of squiggly type equals, the wavy type equals, that means approximately, because this doesn't give us an exact answer. Now that's what part 2 is about. So part 2 says explain with the aid of a diagram whether our approximate value will be an over or under estimate. So what we're going to do with our diagram, well, I'll use the one that's on here as an example. We've gone from 0 to 2. Let's make this doing a nice thin pen for this one. Remember, you can do diagrams in pencil. So we've gone 0 to 2, and we put 4 trapeziums on there. Now, the way it does the trapeziums is they go all the way up to the curve. I've gone slightly too far there. And at the points, with each x value, it goes up and touches the curve. And then, of course, the tops of trapeziums are straight lines. So join all my trapeziums up with straight lines. Now, what's going to happen here? Well, if you join the lines up with straight lines, there's going to be a bit of a gap because the straight lines are above the curve. So the trapeziums are above the curve, so it will be an over estimate. Okay? Now you'll put that in your answer space. I've used that handy diagram. You may be given a diagram to draw on in the exam. But make sure we draw in our trapeziums and show that it is an overestimate. It is worth noting at this point that had the curve been the other way up, like that, in this case when you draw your trapeziums in, oh sorry, that's the ball going slightly out, they will be under the curve, so this will be an underestimate because there's a gap. That's the alternative. Okay, that was not the question here.